Hey guys, check out the boxes shown here. Got a bunch of square roots come out even and some cubed roots that come out even. I'm going to assume that over here on the left that you guys have these guys pretty much memorized by now. But I'm wondering if these guys are something that you have circulating around in your brain. And if you don't, you really kind of need to commit those to memory. And the reason being, and you'll see below, but also the next section, you're going to need to do some factor trees. And it's just so much easier to do factor trees with cubed roots if you have these guys memorized. But for the portion down below, everything's going to come out even for the section 8.2. So you are certainly welcome to use a calculator. All right, I apologize for the fact we're going to squeeze these in. I'll have a ton of room. Not going to bore you as to why, but so the first example here, square root of 144, I think we all know is 12. The x to the third, I'm going to go ahead and give you the heads up on the shortcut here. Square roots are understood to be a root of 2. So how do I get to a 3 and x to the third based on that 2 and 6? Well, you divide them. So if I divide 6 by 2, I get the x to the third. Now, please keep this in mind. If you are in the honors class, I'm going to require that you use the absolute value on occasion, and we'll tell you when to do that here momentarily. If you are not in the honors class, you get to skip that. I'm not going to hold you to that. But here's the reason for it. If there is no plus minus symbol out here in front, then we have to assume it's positive. So if we're assuming it's positive, then that means these answers should be positive no matter what. But what would happen if you stuck a negative number in there for x, if the absolute values weren't there? A negative times a negative times a negative would give you a negative answer. But we just got done saying that the answer to these are supposed to end up being positive. Well, what happens if you force an absolute value around that guy? Absolute values always make things positive, and therefore it would match up and the answer would be correct. It would give you a positive answer. Now, the question is, when do you need to do that? And it's actually pretty simple, just something you have to commit to memory. If you start off with an even root, which in this case we did, and you end up with an odd exponent, which we did, that's when you put the absolute value symbol around it. Simple as that. No other time. Odd roots, don't even concern yourself. Even exponents, don't even concern yourself. It's only this situation right here. So keep in mind, regular level Algebra 2 students, you don't even have to worry about that. You just have to be able to do the problems, no absolute values included. All right, let's skip down here. So I like to call this the McConnell method because Mr. McConnell, back when he used to teach these, would always force his students to do this. And you are entirely welcome to do it. If you do not want to, I'm going to show you a shortcut very shortly. So square root of 81. I'd like to think you guys know that that comes out even and it's 9. But I'm going to go ahead and do a factor tree for it anyway. So factor tree for 81 would be 9 and 9. I keep going. I got a pair of 3's for that first 9. I got a pair of 3's for the second 9. So what's a to the second mean? Well, it means there's 2 a's. And b to the fourth means I've got 4 b's. So earlier this year we did these for square roots. We did circle pairs, and I'm going to show you what to do with the cubed root here in problem 2 shortly, but it would be the same thing. I'm circling a pair. I'm circling a pair. Pair of a's, pair of b's, another pair of b's. So if I have 2 circled pairs of 3's, that means I have 1 3 that goes outside of the root, another 3 that goes outside of the root. I have an A circled or pair, so I use 1A. I have a B circled or a pair of B's, I use 1B, and I got another B. So we finalize that and put it all together. I got a 9. So let's go back to the original problem. Did you know the square root of 81 was 9? I'd like to think so. I got an A, and I got 2 B's for a B squared. So that's a long way of doing that problem, and you are more than welcome to do it that way if you'd like. So one more time, but to illustrate why it's a little bit different, if I go factor tree for 27, I'm going to go 9 and 3. I'm going to break the 9's down, or the 9 down into 3's. And I don't know why on earth I decided to use x to the 9th, but it's my own fault. So I'm going to suffer through it. And I'm going to list them out. 6, 7, 8, 9. So you can see why I think Mr. McConnell is crazy. That's a lot of work. But guys, here's why I put the cubed roots around this. I'm not circling pairs. If I'm doing a cubed root, I want to circle 3 at a time. If I was doing a fourth root, I would want to circle 4 at a time. So let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So how many triplets did I circle? Well, I circled a triplet of 3. I circled 1, 2, 3 triplets of x's. So that would give me 1, 2, 3 x's for my answer. And I have 1 trifecta, if you will, of y's. So that gives me 1 y. So there's the long way of doing that. So you are welcome to do that way if you'd like. For me, that's painstaking. As you can see, after a while, my hand starts to hurt and my scribble looks terrible. So shortcut. So let's do a couple of these before I run out of video time. So I'm just going to ask you, what's the square root of 49? And I'm reasonably confident that you would tell me 7. But the thing you have to remember, guys, is if you're going to tell me it's 7, you didn't say square root of 7. You just said regular old 7, and I'm writing a regular old 7. So the shortcut with the variables, which is awfully easy if you remember it, but we do have to remember that the square root is understood to be a 2. So as stated earlier, you just need to divide those. How many times does 2 go into 10? It goes in 5 times. How many times does 2 go into 6? It goes 3 times. All right, if you are in regular Algebra 2, please ignore what I'm about to tell you. If you're in Honors Algebra 2, pay attention. Notice that we just did an even root, and the result was an odd exponent. So therefore, I have to put absolute value symbols around those two guys. Do not get a choice. All right, so something to consider here, and you can just go ahead and plan ahead. If I'm going to do an odd root for number 4, then I don't have to concern myself with any absolute value symbols. But do you have the cube root of 125 memorized? If you did, you'd know it's 5. And there would be no factor trees to do. There would be no thought involved. So please commit those cube roots to memory. And as simple as this, how many times is 3 going to 27? 9 times and we're done. So again, cube root, odd root, no absolute values to consider. Number 5, cube root of -8. So I did tell you in this section, these all come out even, no factor trees necessary. So you could pick up a calculator if you weren't 100% sure. But let's just consider this. If the cube root of +8 comes out even and is +2, what number times itself times itself times itself would give you -8? Well, that'd be -2. And that's the only difference there with that guy. So no variables, and if there's no variables, I wouldn't have to consider the absolute value either here. Okay. Let's get 6 and 7, and we'll save the rest for video part 2. All right, don't let this next one scare you just because there's more going on. So again, calculator if you want. Cube root of -64 comes out even. It's -4. Both the h and the j, since they're in parentheses, are being raised to the 3rd power. So if I were to divide them, the exponents that is, they would both have an exponent of 1. Wouldn't need to bother writing it. And then for the k, well, how many times is 3 going to 12? Goes in there 4 times, and we're done. So as you can see, this section really isn't that bad. The only thing, and again, if you're in honors class, you don't have to worry about it if you're not, would be the absolute value symbol. This one is an odd root, no absolute value necessary. So number 7, well, the square root of 36 is obviously 6. How many times does 2 go into 8? It goes in there 4 times. And what do we do with this negative sign out front? Well, if it's understood to be a -1, what will be -1 times my answer? Just make it -6 instead. So one more time, you're going to want to double check before you turn in a quiz, before you turn in a homework, and be 100% sure. I just did an even root, and that does require absolute values sometimes. But, let me point it out up here, even root with an odd exponent answer. Well, we did an even root, but we did not get an odd exponent answer. So there is no absolute value required there. All right, guys, stay tuned for part 2 video to check out these last 4 problems. Thanks for watching.